Welcome back to another day of concept number 10. So this is multiplication properties of exponents, day 2. Yesterday we talked about the fact that if you have expressions that have the same base, all you have to do is add the exponents. Today we're going to take it another step further and talk about, well, what if I have an expression that has an exponent on it, and then it's then being taken to another exponent. So this is called like a power of a power. So I have something that already is an exponent, and then just to make things just a little bit more complicated, I'm going to add another exponent onto it, right? So what we're going to do is, how do I even simplify that? What does that even mean? So let's take a minute to take a look at what that means. So I'm not asking you to simplify 5 squared to the third, because if I was asking you to do that, you would just do what was inside the parentheses, get 25, and then do 25 to the third power. But that's not what I'm asking you to do. What I'm asking you to do is, like, let's just expand this. So we're going to work from the outside in, and that's how we're going to do it, working from the outside in. So I'm going to look at my outside exponent. That exponent is a 3, and the base of that exponent is 5 squared. So I'm going to take 5 squared and multiply that 3 times. 5 squared times 5 squared times 5 squared. Well, now I still have an exponent on all of these guys, and it's all still multiplication, so those parentheses aren't even necessary anymore. So I can now break that up into 5 times 5 times 5 times 5 times 5 times 5, right? 2 5s, 2 more 5s, 2 more 5s, to bring me now to a total of 6 5s. This can be written as 5 to the 6th. We're going to ignore the last column until the end. So let's take a look at this then. I'm working from the outside in. So the exponent, this exponent is 2. Its base is everything inside the bracket. Now notice the stuff inside the bracket has another parenthesis. That's because that -3 is being taken to that -2. All right? So what we're doing though, let's look at this 2. This 2 is telling us that we're doing this stuff inside the brackets 2 times. So that's going to look like this. -3 in parentheses squared times -3 in parentheses squared. So the bracket was telling you that that little -3, the negative is included. All right? So now I'm going to break that up even more. -3 squared times -3 squared, well, that gives me -3 times another -3 times another -3 times another -3. So I have 4 total -3s. So now I can rewrite that as -3 in parentheses to the 4th power. And you have to put the -3 in parentheses because you just took a negative to the 4th power, right? The negative was included. You had -3 4 times. You didn't have a negative and then 3 4s. Okay? Now let's look at the next one. The next one, we look at the outside exponent first. That's a 4. That means I'm taking, this is the base of the 4, b squared. So I'm going to take b squared 4 times. So I'm going to write that out first. B squared times b squared times b squared times b squared. So now I can take the b squareds out even further, which now brings me to b times b times b times b times b times b. 1, 2, 3, 4, 5, 6. Oh, I need 2 more b's. Times b times b. So I have a total of 8 b's, which then means I can rewrite the expression as b to the 8th. All right? Now let's take a look at this. This one, my exponent on the outside is a 4. My base is this minus b squared. Okay? So now that negative sign is going to the 4th power, but it's not going to the 2nd power because there's only one set of parentheses. Right? So the base of the 4 is minus b squared. So we're going to do that 4 times. So I have minus b squared times minus b squared times minus b squared again times one more minus b squared. All right, so now let's be careful here. That 2 is only attached to the b. Remember from yesterday, these negative signs, that negative sign out there, it's going to act like a -1, okay? So we're going to treat this like it's a -1 times b, and that's how we break up each one of these. So we're going to write -1, -1 times b times another -1 times b times b times another -1 times b times b, and then we have one more, right? Another -1 times b times b. So now if I take a look at this, if I'm going to multiply all of this together, let's look at the negative ones first, right? Because the b's is a value we don't know. We can do -1 times -1 times -1 times -1. And as we learned yesterday, if you have an even number of negatives, that ends up being a positive. So all of this just ends up being +1. And +1 times all of these b's is just going to leave us with those b's. So how many total b's do I have? I have 8 total b's. So we're going to put that right there, 8 total b's. So now when I rewrite this answer, this is also just b to the 8th. And it's positive b to the 8th because the negative was being taken to the 4th power. All right? Let's go ahead and take a look at the next one. The next one, again, here, when I go to expand this, that 4 is saying that every single thing inside these brackets are what's being taken to the 4th power. So I'm going to write this to the 4th power. Okay? So when I expand this, it looks like this. It goes -b squared, and the -b goes in parentheses, times -b squared in parentheses, times -b squared again, or -b in parentheses squared, times one more -b in parentheses squared. So now when I go to write this out, all of those negatives, they are inside parentheses with the 2 on the outside of the parentheses. So when I break this all up, I have a total now of -8. I have 8 negative b's. So I'm going to write this now as -b times -b times -b times -b times -b times -b, 1, 2, 3, 4, 5, 6, another one, 7, and 8. So we have 8 total negative b's. And so I have 8 factors again, but now when I write this, this is actually -b, and the -b is in parentheses. That's to the 8th power. Okay? The negative was included inside the parentheses with the 2 on the outside, so we had to take the whole thing. It's a little tricky with these negatives. All right? If you feel like you've got it, go ahead and stop the video and expand the next 3, and then come back to me, and we'll check it together. All right, so when you expand these next ones, you should get this. It goes x to the 3rd times x to the 3rd, because you're taking that to the 2nd power, and then you break that down to x times x times x times x times x times x, right? Because I had 2 sets of x to the 3rds. That is a total of 6 x's, and that's going to be written as x to the 6th. The next one, you are now taking the minus x to the 3rd to the 2nd power. So this gets written 2 times without the parentheses, right? Because there's not a double set of parentheses. So it goes minus x to the 3rd times minus x to the 3rd, like this. So then when I expand that, very tricky, that minus sign is not being taken to the 3rd power. It's -1 times x times x times x times another -1 times x times x times x. So now because I've got 2 -1s here, -1 times -1, that's now +1. So I don't need to worry about the +1 because +1 times all these x's is still going to give me 6 x's, which I'm going to write as x to the 6th. All right? Now the next one, this 2 on the outside is telling us to do what's inside the brackets twice. And what's inside the brackets are parentheses. So I'm going to do -x in parentheses to the 3rd times another -x in parentheses to the 3rd. And so when I go to expand that further, you have -x times -x times -x times -x times -x times -x. We have a total of 6 -x's, and when I write that, it's -x to the 6th. Okay? Now let's take a look at the very last column here. The very last column, what I'm trying to get at again, like I did yesterday, is how do I get from this column here to my final answer without really having to do all of this, right? And again, we're looking at our exponents. So if you look up here, the exponents I have were 2 and 3. I ended up with a 6. If you look, isn't 2 times 3 6? Here, I have 2 and 2. I ended up with -3 to the 4th. Well, isn't 2 times 2 4? So what we're doing, let's go through and just multiply the exponents. 2 times 2 equals 4. Now the exponent in the next one, b to the second, b to the fourth, well, 2 times 4, that's 8. And isn't that the exponent that we got right there? And same with the next two. Your exponents are both 2 times 4, which is 8, 2 times 4, which is 8. And then the last three, they were all 3 and 2. Well, isn't 3 times 2 6? 3 times 2 is 6. 3 times 2 is 6. So, with the problems where we're taking a power to a power, meaning that we've got an exponent that's right outside a parenthesis, and then we've got exponents on the inside of parentheses as well. When raising a power to a power, what do? We multiply the exponents. So that's what we're going to say we do. We're going to multiply the exponents. So let's go ahead and try some of these. If you feel like you've got it, let's just go ahead, just pause me, do these, and then double check to make sure that you've got the right answer. But if you don't, stick with me and I'll do some little bit more explaining. So A, all we have to do, power to the power, just multiply our exponents. That gives us y to the 12th. This one, 7 times 20 is 140. We do j to the 140th. Now the next one, notice that that negative p is in parentheses being taken to the third power again. Our exponent is going to be 9, but negative p does have to go in parentheses. So it becomes negative p in parentheses to the 9th power. Okay? This next one, g to the 50th. The next one, be very careful. The negative sign is not being taken to the third power. It's not being taken to the 5th power. It's being taken to the third power. So in the end, my answer is going to be negative because the outside exponent here, that outside exponent is odd. And we're taking a negative to an odd number. Okay? We don't necessarily need to have the parentheses here. This is just negative d to the... All right, now the next one. We are going to multiply those two things together, 3 times 2, but we've got this internal set of parentheses. So that internal set of parentheses, it's got to stay there. So we're going to put negative a in parentheses, multiply the exponents, and it becomes negative a to the 6th power. Now you can leave it like that. You understand that the negative a has to go in parentheses. You could take it a step further and know that this answer in the end, because that's an even exponent on the outside, you could take it a step further and know, well, this negative a, it's going to end up becoming positive because we have an even exponent. You could end up saying that this is also just plain old a to the 6th. All right? But you're really only required to take it this far right now. Okay? Now, I definitely want you to stop the video and do these next ones on your own. When you're finished, start the video back up and the answers will be here. All right. Now I'm serious, if you didn't do these on your own, you really should, because it's not going to do you any good to just write them all down, right? You really want to think about them. So go ahead and take a look at the ones. Check your answers. There's a couple that I just want to point out. This one right here, notice there are no parentheses around the negative y. All right, there are no parentheses around the negative y because that negative sign is inside the parentheses with a 3 on the outside. So because there's a 3 on the outside, that negative is going to end up being negative because a negative to an odd power gives us a negative. The only thing being taken to the 12th power is the y. So they're like kind of separate entities. If you're still like confused about this, we're going to hit it some more. All right. Notice that this one right here, C, that one has to be in parentheses. That negative p has to be in parentheses. If you took it a step further and called that one p to the 6th, that's okay, because that negative now is taken to the 6th power, which is going to end up making this whole thing positive. But you could have just left it like that, okay? This one, the negative d, does start in parentheses. Technically, you could take this a step further because a negative is taken to an odd power, and that will end up giving you negative. So this answer could look the same as this one, okay? But I want you to understand that it initially started with parentheses. Now F, this is the only answer you can give me, because if you look, that negative sign is within the parentheses right here with the 2 on the outside. The 3 is directly attached to the A. So only the A is going to the 3rd power, but then it's going to the 2nd. So that becomes 6. That negative sign becomes to the 2nd. If this one you're struggling about, don't sweat it. We're going to figure it out in the next section. All right, this next little section is now talking about a power of a product. So if you look here, what you have is more than one thing happening inside the parentheses, which is kind of similar to what we did in the last problem where there's that negative and a letter. There were really two things inside those parentheses. So we're going to talk about what do we do when there's more than one thing inside the parentheses. So again, let's look at the expanded product. Here we've got 3 times 4 to the second power. If I'm going to expand that, I'm not asking you to simplify it. Like I'm not asking you to figure out the answer. I'm saying let's just expand it. What does this mean? So if I do 3 times 4 twice, there we go, 3 times 4 twice, the parentheses are not necessary, right? So we can just remove those parentheses because it's all multiplication. I get 3, it looks like this. And then let's go ahead and rearrange those numbers. And remember, the property that tells us that we can rearrange numbers within multiplication is our commutative property. So we're going to go ahead and write the commutative property here. And I'm going to abbreviate it. Commutative. All right. Remember, commutative has a T in it, not commune. We're not communing with numbers. We're commuting them. All right. So now let's take a look at the next one. The next one, I've got 2xy to the third power. So essentially what that means is I'm doing 2xy times 2xy times 2xy, right? And we did start it off in parentheses, okay? But the parentheses are completely not necessary because everything is multiplication. So I could just say it's 2 times x times y times 2 times x times y times 2 times x times y. Now let's rearrange it so like things are together. So what I end up having here is 2 times 2 times 2 times x times x times x times y times y times y. And now I can rewrite that, if you look, as 2 to the third power, x to the third power, y to the third power. All right, let's take a look at the next one. The next one has negative 2w on the inside of the parentheses. So what that means is I'm doing negative 2w 4 times. Negative 2w's. My w's are starting to look a little bit crazy, huh? Negative 2w 4 times. If I break it up without the parentheses, that just means negative 2 times w times negative 2 times w times negative 2 times w times negative 2 times w. I didn't leave myself enough room here. So now I'm going to rearrange it. So I put all the negative 2's together, so that gives me negative 2 times negative 2 times another negative 2 times one more negative 2. We have 4 negative 2's, and then we've got 4 w's, right? w times w times w times w. So now I can rewrite that as negative 2 in parentheses, because negative numbers, 2 powers, must be in parentheses. Negative 2 to the 4th power, w to the 4th power. Okay, now all of these in the very last column, they are not fully simplified. What we're trying to do is just see, do you notice how we're getting from the first column to the last column? And a lot of you might just start to see that, okay? The next one, let's take it, negative 3w to the third. So we're going to do negative 3w times negative 3w times negative 3w. Remove the parentheses, and that just gives us negative 3 times w times negative 3 times w times negative 3 times w. Rearrange it all so that it's negative 3 times negative 3 times negative 3, and then w times w times w. Now if I'm going too fast, please stop the video and just look at what I'm doing, all right? So now take the negative 3 in parentheses. We have 3 of them, so that's negative 3 to the third power, w to the third power. Are you starting to catch on just a little bit? How am I getting from the first column to the last column? If not, let's go keep doing it. So the next one, I've got negative 4x to the second y to the second power. So that means I've got negative 4x to the second y twice. Remove the parentheses, that means negative 4 times x times, I'm just going to say x squared here because I know you mean that means x times x, right? So negative 4 times x squared times y times negative 4 times x squared times y. And now let's just rearrange everything. I'm going to have negative 4 times negative 4 times x squared times x squared times y times y. Put it all together. I have negative 4 squared x squared squared, all right? Which we can do something with that, and we'll talk about it in a minute, y squared, okay? All right, now the next one, I've got negative 2x to the third, y to the second. How many times do I have that? 3 times. So I have negative 2 x to the third y to the second, negative 2 x to the third y to the second. Go ahead and remove those parentheses. That means negative 2 times x to the third times y to the second times negative 2 times x to the third times y to the second. I'm going to have to write the next one underneath it. Negative 2 x to the third times y to the second. So now if I rearrange everything, I've got how many negative 2's go together? So I've got negative 2 times negative 2 times negative 2. I've got x to the third 3 times, and I've got y to the second 3 times. Okay, so now I'm going to put that down here because I'm totally running out of room here. So I've got now, I can rewrite that as negative 2 to the third power, x to the third power, y to the second power. Okay, now I want you to understand this last column, none of them are fully simplified, but it's a good place to start to get them fully simplified. So if you look, what I just did is I took a product raised to a power. Now let's take a look at this. I had 3 times 4 to the second, turned out to be 3 squared, 4 squared. 2xy to the third turned out to be 2 to the third, x to the third, y to the third. Here, my exponent was 4. Well, then I ended up with 4 on every single term, right? So are you seeing that the exponent then ends up on every single term? Now, let's go ahead. I just want to kind of talk about this down here. Down here, negative 2 to the third, you can figure that out. X to the third, that, you can just multiply that. Y to the second, you can just go ahead and multiply that. So when we fully simplify this stuff, you are going to multiply the stuff out if you need to. But the point that I'm trying to make is, what am I doing with this exponent on the outside of parentheses? What I'm doing with this exponent on the outside of parentheses, and I'm just bringing it in, and I'm applying it to the exponents on the inside of the parentheses. So when a product is raised to a power, the rule is that you apply the outside exponent to all of the factors inside the parentheses. So that's what we're going to write. When a product is raised to a power, we apply the exponent to all factors. And that really should be written on the line. I just went a little crazy because I'm running out of room. All right, let's do some examples. So basically, letter A, all of this stuff is being taken to the third power. We can just bring the 3 on the inside and call that A to the third, B to the third, C to the third, D to the third, right? Now, letter B, we can make that 4 to the second, M to the second, P to the second. But that can be fully simplified because we know what 4 to the second is. 4 to the second is 4 times 4, which is 16. So we are going to take it one step further and call it 16 M squared P squared. All right, so we are going to take them one step further. The next one, that negative 2 inside parentheses being taken to the fourth power. So we're going to do negative 2 to the fourth power, R to the fourth power, S to the fourth power. Negative 2 to the fourth power is 16, right? Negative 2 times negative 2 is 4, times another negative 2 is negative 8. Negative 8 times another negative 2 is positive 16. So this becomes 16 R to the fourth, S to the fourth. All right? The next one. I'm just going to do this one in my head. Negative 3 squared. Negative 3 squared is positive 9, right? Negative 3 times negative 3. Then G to the second. And that's our final answer. Okay? Take the negative 3 to the second power, take the G to the second power. All right, so now when you have other exponents in here, before I was writing it as like A to the second to the third, B to the third to the third. But when you're taking a power to a power, really what are you doing with your exponents? You're multiplying your exponents. So now if you're taking an exponent from the outside of parentheses and you're bringing it in, and there are other exponents, just multiply. So this now just becomes A to the sixth, B to the ninth, C to the 12th, D to the third. All right? The next one, I'm going to do negative 5 to the second power. Negative 5 to the second power is 25. Then I've got M to the 6th, P to the 10th. Feel free to stop the video, try the next two, come back to see if you've got it right. If you've done that, the next one, we're going to do negative 2 to the fourth power. Negative 2 to the fourth power, 16. R to the fourth, s to the 24th, okay? So I just want to reiterate, the -2, it essentially has an exponent of 1 on it, and the r essentially has an exponent of 1 on it. And so when we're bringing it in, we have to bring that 4 to everybody, including the -2. All right? So this, like, essentially has a 1 exponent on it. So we do -3 to the 3rd power. That's -27 g to the 12th. Multiply your exponents. All right, now let's look at examples that combine all these different properties, the properties you learned yesterday and the two big things that you learned today, okay? So let's go ahead and take the stuff, this is all variables, all right? So let's back up. Suppose I have m to the a times m to the b. This right here, m is your base of the exponents a and b. So this is very similar to what we learned yesterday. In fact, it is what we learned yesterday. If you have the same base and you're multiplying, what you're doing with the exponents is you're adding them. So this is going to become m to the a plus b. That's what you're doing. You're adding the exponents. The base stays the same, you add the exponents. Now the next one, mk to the b. That b is on the outside of parentheses. I'm just going to bring it in and make it m to the b, k to the b. The next one is taking a power to a power, right? That b would then get applied to the a through multiplication. So this would end up being m to the a times b, so m to the ab. All right? Now the next one is a little bit of a trick question. To figure this out, it says m to the a times n to the a. The a is the exponent. It doesn't matter that they have the same exponent. That doesn't matter. What matters, if you're trying to combine two things by multiplication with exponents, they have to have the same base. So technically, this one, you can't simplify really any further. It would just stay m to the a, n to the a. Technically, you could take it backwards to look like the problem in number 2. You could say that this is then just an mn in parentheses, the whole thing to the a. Both of those mean the same thing, okay? But like really, there's not a whole lot of more, you can't really simplify that. So just to recap, I just want to recap the 3 rules we really learned yesterday. So yesterday we learned this one. If you have the same base and you're trying to multiply, you add the exponents. Here, if you have more than one thing happening inside your parentheses and outside the parentheses there's an exponent, you just apply the exponent to every factor on the inside. And then here, if you've just got something that has an exponent and you're taking it to another exponent, you simply multiply those together. So what I would like you to do now is I would like you to stop the video and work on the rest of the problems on this sheet. And go ahead and look around your table. If there's somebody at your table that's pretty close to being done at the same place as you, then go ahead and start working together and see if you can come up with these answers together. Once you have the answers, or as far as you can go, I want you to tune back in, and these answers are going to be right here for you. So these first 3 right here, notice there are no exponents on the outside. So these 3 problems are just like the problems you were working on yesterday. You just multiply the big numbers, add the exponents. There's no multiplying of the exponents because there's not an exponent on the outside of parentheses. So here, all I did was add the exponents, multiply the big numbers. Let's go ahead and take a look at the next 3 right here. This one, I want to point out that here you're bringing the 6 in to everybody. That minus sign right there, not technically connected to the x. It is -1. So I just wrote this as -1 to the 6, x to the 6, y to the 12th, and then -1 to the 6th, a -1 to the 6th power is just a +1. So that kind of cancels out because +1 times x to the 6th times y to the 12th just gives you this right here, x to the 6th, y to the 12th. This one, bring in the 4 to everybody. Don't forget to bring in the 4 to the 2 and get a 16 here, because 2 to the 4th, you didn't do 2 times 4 here, you're doing 2 to the 4th power. Then you're multiplying your exponents, and that's how I got a to the 8th, e to the 4th, u to the 12th. This one, I will admit, I stopped. I don't want to do 6 to the 5th power, and I really don't actually expect you to do 6 to the 5th power. Eventually, we're going to have calculators, and you'll be able to get that. And I'm not saying you can't do that. You can. It's just time consuming. You don't need to waste your time doing that right now. But I do want to point out to this, a lot of you might have gotten this answer, but in a different way as I did. A lot of you might immediately brought that little 5 from the outside into everybody, but then you have to realize that you've got some things inside here that you can combine together, okay? So what I did first is I went ahead and I looked inside these parentheses. Inside these parentheses, you can actually combine the 2 and the 3, right? 2 times 3 is 6. P to the third, I just brought down, and then R to the fourth and R, I just put that together. That's R to the fifth. So on the inside, I added the exponents that could be added. I multiplied my coefficients. Then I'm bringing in that 5, and that's how I bring the 5 to everybody. So if you brought the 5 in to everybody first, that's okay, but then look, you have to combine your R's, and then you have to combine the things that you multiplied together, the 2 to the fifth and the 3 to the fifth, which makes things a little bit harder. All right, so now I'm going to go ahead and do the next one with you, number 11, because I want you, when you've got, this has everything in it. So if you look, there's an exponent on the outside, and there's an exponent on the outside here. You could immediately bring that into everybody if you wanted to and get rid of the parentheses. But I have advice for you that if you look inside these parentheses, if you can combine things inside the parentheses, sometimes that makes the problem a little bit easier. So if you look inside these parentheses, I can put the C's together. Okay, this is C to the fifth times C to the third. Don't forget you're adding your exponents here because you've got 5 C's and 3 C's, which gives us a total of 8 C's. So that inside part, I'm going to make 3C to the 8th B, take the whole thing to the second power. And then I'm going to do the other one, I can combine the B's together. So on the other side, I'm going to get 2B to the 5th, add exponents. C to the 4th, the whole thing to the third power. All right? Now, we are going to imagine there's a little 1 on this 3 and a little 1 on this 2. So when I now bring in the 2 from the outside here, I don't forget about it. You have to do 3 to the second. 3 to the second is 9. Then you multiply your exponents. C to the 16th, B to the second, bring the 3 into the other set. So then you have 2 to the third. 2 to the third is 8. B to the 15th, we multiply C to the 12th. So whenever you bring, the only time you're allowed to multiply your exponents is when you're bringing it from the outside to the inside. And so now my next step, I can combine all of this together. 9 times 8 is 72. Combine your C's, so C to the 16th can get combined with C to the 12th to give me C to the 28th. And then the B to the second, B to the 15th can give me B to the 17th. And that answer is 72, C to the 28th, B to the 17th. Okay? So I worked from the inside, then I brought the exponent from the outside in, and then I multiplied everything straight across. You multiply your exponents when you bring it from the outside in. You add your exponents when you're multiplying straight across. And then remember, the bigger numbers, they're not exponents. They're just regular numbers. We're just multiplying 9 times 8. Not a big deal. Stop the video now. Do 12, 13, and 14. See if you can get them without my help. And then tune back in. The answers will be there. Okay. Take a moment to examine the answers to the rest of the problems. If you got one wrong, stop the video and look at my work and see if you can figure out what you did wrong. And of course, help each other. See you soon.